My name is Kaplun. I would present today our CiA automation webinar for CiA Excel status and future. For the moment, there is nothing actually required from you. Knowledge of CiA is, of course, of advantage. So, several slides I would just speak about, introduce to CiA automation, what we do, why we do this, and so on. Then we start in a structured way, going through the CiA Excel as the third technology, CiA technology. We look into details, into different ISO-OSI layers of it, and try to grasp the whole concept, what is going on, why it is so, and what is the reason to having this anyways. So, I'm an electrical engineer working at CiA automation already 15 years, nearly 15 years. I do supervision, let's say, maintaining the documents we specify at CiA automation in various technology fields. Says all three CiA technologies, CiA Excel, CiA FT, and Classic CiA. I'm supervising special working groups that write specification for CiA Excel. And beyond this, also higher layer protocols that we originally developed ourselves, CiA Open, CiA OpenFT. Additionally, I do test devices at CiA automation and supervise also more marketing and technical testing events, such as we call it Plugfest. This year we have also a couple of weeks back, we have a CiA Excel Plugfest. The results are not yet available. As soon as they are here, we will share this with you. Besides of this, I'm also participating in standardization, as I'm an expert from CiA automation in the area of the drives. So far about myself. What is CiA automation? Why it is interesting for you? What we can do for you? So CiA automation was founded more than 30 years ago. The reason was to provide some technology information on CiA-based protocols to the wide number of companies and all interested parties who would like to know more. At the beginning, it was mostly available only for automotive. Then the interest in various other industries become obvious, so CiA automation was founded. So these 30 years, we have established a social network of the people who we know. We collected some knowledge. So if you need anything about CiA, please contact us. Where you can do this, where you find us, how you can contact us. This is our location, the only location of CiA automation in Nuremberg, in Germany. It is in the city, nearly city center. So it is easy locatable if you travel. But if you contact us by electronic means, email, phone, and the other emails at the end of our my presentation here, my webinar presentation here will be shown to you. CiA automation is actually an organization, so we finance ourselves more or less with the services, and this membership organization. As of right now, you see we have more than 740 members. In the course of action, it started 1992 with only few companies and some people who are still a member of CiA automation. And over the course of years, as you can see, there are a steady number of our members. Is not steady, but is growing. This is not the point of growing, but the interesting point is that CiA technology is still at large, or at least interesting for many parties. So what are our services? Most of all, we design specification. What is this all about? So if you develop device with a certain communication technology, you need to specify requirements, guidelines, whatever you need to design a device. And this is what we do with our members together. And there are several activities, technical and marketing activities that we have to promote this specification, promote technologies, and spread this specification across various media that they reach people who would need them. So on the left and right, you see technical and marketing activities that we do. In the next one, I will start with marketing activities. Our member request us to explore some marketing opportunities for them. And we do this, we go to exhibitions, we go to find and look for the markets. Our members want us to represent them, and this is what we do on the marketing side of this. This whole one is controlled by, as you can see in the top, business committee decides about how the members' money are spent to which activities. Second one is more tightly related to specification. There are technical groups which come together and write specification. We, as technical secretaries, put this in document format of CiA automation, and also our activity is to help out and move support our members if the specification is going to be standardized in one or another standardization committees, such as an ISO, IEC, and the others. So at the top of this all technical committee, differently as the business committee decides which technical direction, technology development we go and our members want to go. Due to the free CAN technologies recently, we have to partition this whole group hierarchy we have at CAN Automation to separate and manage actually the work of these technical groups. There are so many things we have to define. So we said there are lower layers where we have data link layer and physical layer of all three technologies. There are many working groups working on them, such as CAN-FD, Classic CAN, CAN-XL, CAN-FD Lite, data link layers and physical layers, some additional stuff like special transceivers that with reduced voltage, like 3.3 volt transceivers, and so on. There are also higher layer protocols in groups that we have to manage. CANopen, Classic CANopen, CC is Classic CANopen, CANopen FD, and also J9039. That is also profiles. There's device and application profiles where we describe their application data. They can be mapped on each of these CANopen-based technologies and even onto J9039 today, nowadays. So beyond this, there are also neighboring topics such as redundancy concept for device networks and safety and security. There is so much to define there as well. So our members said we need separate big groups to manage them all. So then they learned about business concept of us, marketing groups and technical groups, and our services more or less. The membership benefits are listed here. You have access to the document. You can participate, improve specification, bring your requirements to the specification, have a voice in a technical group. and also can request us to open certain markets or look into certain markets to promote your products. This is what we do as well. So far about this general introduction to automation. Now I would do a small introduction, short introduction into CAN Excel. So as I said, there are three technologies. If you are familiar with them, this is okay. We will talk about the third one, with newest technology called CAN Excel. Is extra large, allows up to 2049 8 bytes, 48 bytes longer than Ethernet frame, allowing Ethernet frames to tunnel through the CAN network. That is the biggest advantage so far in there. But briefly to the history of CAN, it started with a Bosch a long time ago. 10 years later, a couple years later, the second Bosch specification, the CAN 2.0b, including R, was specified in ISO 11898. And then it was too much. Then in 10 years, there was a need to separate requirements for protocol controller and transceiver that transmits the data itself into different parts of the standard. To test this, both protocol controller and transceiver have to be validated, especially for automotive, to allow it to use in various cars across, or vehicles across the planet. So there was a necessity to develop a test plan, conformance test plan for them. Was designed in 2004. Then the new additional media access, so for transceivers, came up in there 2004, 2007, time-triggered CAN, a low power and selective wake-up physical layer. Physical layer for selective wake-up was also too mighty that it was needed several tests to verify how good it performs. And finally, we have next stage, we had new technology, we have CAN FT, and this where it come again. We have next version of the standard, and it includes already both technologies, classic CAN and CAN FT. Then also for transceivers that support both, and test plans that could be used for test to validate both of them. Finally, this year, we have released this third technology, CAN Excel, by ISO standard, the same ISO standard. Now it contains 3 protocol technologies and plenty of physical layer stuff, such as just normal, usual, typical transceivers, even for classic CAN, up to signal improvement transceivers and transceivers with supporting various additional features. Everything is inside now. Please be aware that for your information, it's also additional, more or less, application design stuff, so-called CAN FT Lite, is also integrated this, but it's not a topic of today, but it is integrated in the -1 as a protocol inside as well. So far about the history. Now it is time to talk what is the reason for all this stuff. Why shortly after after CAN FT, automotive requested some much higher speed, bigger, larger payload protocol supporting CAN. The reason is actually that vehicle architecture evolving constantly. And the problem is that there are many control units. Many devices are already put in a car, starting with the very early cars with only few control units and sensors and whatever actors inside. We have now the whole pieces of the car that have plenty of networks inside. They have performed various tasks in there, and the number grows. So the second one after the simple networks was this domain architecture. That is, all the stuff was splitted, and the car central processing unit has accessed over the domain controller several domains of the car, so-called, which have plenty of networks, but the operation was more or less smooth, and the devices and sensors were close to each other. So the communication distance was close, so it could save also cable, but also have more improved communication between the components. So the component and the speed of communication requires to have more. So the domain concept, as you can see in the above picture, doesn't fit anymore. So this domain controller has not enough power to handle this 4 or 5 segments of networks with 20 or something devices, whatever sensors and so on. Sometimes the sensor may be located in a different domain, so the access to this will go through the whole network around. So the people said, okay, we need another approach. The zonal architecture was born. In this case, the parts of the car are separated into not the domains, but by the functionality, but by the location in there. So instead of having domain controllers as ones, there is a gateway which has enough processing power to manage various protocols, to manage various types of devices and the sensors connected jointly to this gateway. So this means gateway is connecting over so-called small domain controllers, and we have some smaller networks, but they are much more closer by each other as even in domain architecture, also saving the cables, but allow better scalability and allow software approach for for the frameworks to perform various access and handle multiple protocols in there. That domain approach, that zonal approach requires, however, much higher speed. So, and plenty of the data throughput, plenty of the data coming through to get this across this whole network and communicating between the elements of these zones. So the requirements are pretty clear. Here in this slide, I have listed some more of them in there so that you can more or less grasp the concept behind of this zonal architecture, more of the requirements to this architecture, that is scalability, higher speed, integration of legacy networks is also required, and various protocols, not only CAN, but let's say Ethernet could be integrated in there. So how can we manage this in one piece? We will see in the next slides. Then from there we come to the CiA, how it is developed. It is coming out from these requirements to the zonal architecture. So the Robert Bosch company designed a third CAN communication protocol that would satisfy the need for zonal communication. It has following properties. One, it uses very large field, very large payload. And due to this very large payload, the overhead bytes that are more than, for example, Ethernet bytes could be used as control bytes for controlling and managing information flow in the network, and still allow to tunnel such large messages as Ethernet based. So the key features are priority ID. So to keep this compatible with the older technology, the CanXL maintains backward compatibility to CANFT protocol. The checksum, or let's say protection of the data, occurs not with a Hamming distance 4, but now 6, but it's still possible to detect every 5 random errors in the network. So for hard synchronization, we have starter frame and ender frame. It is still the same as in classic CAN and CANFT, so it's for advantage. They're more or less tolerable in across the various CAN technologies. There are some new things introduced to keep and maintain and hold up with high layer protocols and address the issues or requirements we saw in previous slides for the zonal architecture. We have compiled also the list as travels across some presentations in there. I call it not a comparison, but rather an evolution. An evolution of CAN data link layer. You see the columns with all 3 CAN technologies, CANXL, CAN CC, which is classic CAN that you know of, CANFT with flexible data rate, and CANXL. All 3 technology exist at the same time. This is just showing that what is CANXL, what does it have that the others don't have. So payload, surely, yeah, with overhead, you could put the whole Ethernet frame inside. Priority identifier. So even a classic CAN has it, could use it 29-bit for large trucks in J9039 systems. In CANXL, people said, no, we don't need this big, we do not use this priority identifier for anything else except priority of the message itself. That will be sufficient. Regarding addressing, it was not available, could be done, and it was also done, especially by us in CANopen and CANopenFT. Addressing was used to providing physical address addressing of the nodes itself. So you know exactly where the communication goes straight. I've put in brackets, in round brackets for CAN-CC and CAN-FT. It could be done, but it was not a part of original data link layer. While in CANXL, it is a part of original data link layer. So in CANXL, you can actually, in 32-bit, provide the address of the device, whatever is encoded in there. So you know exactly where the message goes into. There are also 2 fields. I would shortly stop on them. SDT and VCID. They have special meaning. For higher layer protocols, they identify a type of protocol itself, and the second one allows to partition the network into smaller, more segmented networks and providing their addresses inside. quite useful if you have this zonal architecture. Then you have to make some topology, let's say, a recognition of the topology, what is inside of networks. So network become more partitioned in there. So the usual key features of CAN messages, CAN communication, bit stuffing started with classic CAN. It was more complex in CAN-FD because we have much larger frame. We need some fixed stuff bits to allow so-called soft synchronization. And in CAN Excel, due to a very large chunk of the data, or very large payload, we need to see how to detect errors. So whether some places where the bits stuff bits are fixed, especially in a data phase, and so on, is more complex handling as it was there, but it's still possible to make it. So protection of the data of the frame itself was available, as you can see here, 15-bit usual CRC for CAN. In CAN-FD it was already more complex one. We need 2 of those depending on the size of the frame. 21-bit for the complete extent, 64 bytes. And another one was to about the third of it. In CAN Excel, due to the large chunk of and some additional key features, it is no longer possible just to use some of those. It is a need for protecting some control bits, bit fields, and also to maintain, keep control between data protection and these control bits to maintain validity of the frame structure in there. So there are 2 CRC for each message is required, no matter how small it is. So we will talk about this also later. We have a slide for this. I have a slide for this as well. Error signaling. Error signaling, well, okay. Always on, the mostly interesting feature, an important feature of CAN. Error detection is globally available in the network. Have error message. All devices recognize it on a bus. But in CAN Excel, it will be a little bit tricky at a certain point if the message become too large and transferred with a high speed without any interruption. There is necessity actually to put this one into certain condition, at a certain condition, and at a certain condition, sometimes the driving to the recessive edges could lead that there are several recessive edges occurred, so the devices wouldn't know if they have to synchronize on this error signal or not. So that is where in this case it is possible to switch. It has to be switched off. So then below you have also fast mode switch. It is done in controller and it switches the transceiver. It is also configurable, can be switched on. That is also allows the possibility to transmit the XL part with, as we said, up to 20 megabit fast with this switch, without having anything else, but it's a special mode required for this one. So it is available only for XL message. So finally, the list of how the bit is distributed, what we have. We keep the arbitration phase bit because we need to detect in the first place, what a type of the message we're talking about is a classic CAN, CAN-FD, or CAN-XL. And when we submit a payload, then it is most certainly required to transmit it with much higher speed. So we call it data phase. It is surely only available CAN-FD. In CAN-XL, it is also available since we have to transmit the data up to 20 megabits. At last, there is also a bitrate ratio, so payload ratio, let's say in this case. So you can see the effectivity of the transmission could be 16 times. We see later a slide about this one, where we could recognize how much of this actually is possible in a real, under real condition. So far about this evolution. Then we look into the frames itself and see what is actually changed in comparison to the previous one. We've talked about several fields that are new in CAN-XL. They have certain properties for higher layer protocols embedded into the frame itself in their every single bit in this case, in case of CAN-XL, is also flexibly configurable. This is also new stuff in there. We take a look into details, into the bit fields inside. What is the new in there? How do we handle them? What is different in CAN-XL? How does it help if you have also FD and classic CAN? So I'll briefly do an overview in here. For arbitration field, we have a priority field. Then in green marked, we have to distinguish to understand, to recognize what we have on a bus now. Is classic CAN message, is CAN-FD message, or is CAN-XL? So with CAN-XL, additional XLF bit is added. In case of XLF, both bits are equal to 1. So you know that this is about the CAN-XL message will be transmitted in there. Below, in control field, you start see from left to right, also green marked. There are additional bit fields, some mysterious bit fields, but they have their own reasons. They're helping the switching the transceivers into much higher speed to overcome any limitation by the speed before. And these bit fields called AGH, DHS, and in a frame in the ISO standard, which is now available, you can see which of them will be synchronized when the switching of the transceiver into much higher speed takes place. Additionally, you see here also these bit fields we talk about, this STT for higher layer protocol, this is SEC bit field. Then you see also PCRC, this is prephase CRC over this control field. Then VCID logical routing addresses of the message where it should go. Then in CRC field, we have a 32-bit frame CRC, which covers also the prephase CRC of the control field in there and protected. And allow, as I said already, up to 5 distinct errors to detect by the CAN controller, CAN-XL controller. Finally, in acknowledge field, it may be necessary, or it is necessary actually, to turn off the transceiver special fast mode for fast transmissions into a normal mode, so the hard synchronization by the ender frame could occur, and the next node, whatever it is using, can start its transmission. So now we talk a little bit about these features we have in there. And the next one will be to see what effect in higher layer protocols, what are the functions for higher layer protocols are already embedded into the message itself. So I call it cascaded CRC because prephase CRC for control bit is also covered by the frame CRC, which calculates also it inside. And there are also universities working on checking the reliability of the data frame, CanExcel data frame, saying in seeking to find the proper expression for CanExcel residual error probability. As I said before, both CRC in working together allow to detect every 5 randomly distributed error in across the frame in there. So reaching effectively then Hamming distance 6 instead of 4, which was available, but still it is a big leap considering the large size of the payload. So now we come to the higher layer protocols. What is in data link layer already inside, which gives me the information for higher layers, such as J9039, Ethernet frames of special kind, MAC frames, maybe also Knopen-based one, and proprietary automotive application layers. So we said that we introduce STT field as a type, service data unit type. Show me exactly the number or coding and encoding for this special protocol type, higher layer protocol type. This STT one is controlling also 3 other distinct fields and controls how to use them. It controls then VCID, then acceptance field, which is addressing of the device, addressing of the message where it goes for routing, and finally also the data frame itself. So that is for higher layer protocols, which we come again in several slides. But for the moment, I would like to draw your attention to the payload ratio we see in case of CanExcel. Comparison to the previous protocols for more or less, it isn't actually comparable, but it says more advanced things as the effectivity of CanExcel, assuming if the others could have the same speed and the same payload, although they can never have it. So the effectivity grows, of course, with the larger speed and the higher payload. So the operating mode was set previously for transmitting the data much faster. So the controller can turn transceiver into faster mode to transmit up to 20 megabit in a data phase. In this case, however, the error signaling has to be disabled because there is no need to synchronize that much except at the receivers. And the faulty data will not be able to be detected, so it is disabled. So far about data link layer, we see the effectivity optimization with a higher payload and faster speed of 16 megabit per second of CanExcel. Low something. Then we haven't spoken about transceiver. What does transceiver offers? We have transceiver for every technology type. Due to certain issues at higher speed sampling of the data, it is necessary to introduce certain circuitry who will reduce ringing effect. We call it now in standardized way signal improvement capability. And already FT, CAN-FT controllers, CAN-FT transceivers, sorry, they do have this capability. But it goes, of course, more critical with increasing speed, where very short time frame for the sampling of the message, and very short time until the signal improved is kicking in. So at this higher speed, they have to be switched anyways, used only these SiC transceivers for that reason. CanXL does have SiC transceivers in there, and it is turn off almost all time, especially for very high speed. In the second slide, one or two, we will see how does it look like in type of transmissions, where and which kind of modes should be switched on to allow certain communication speed. So now is but the table similar to that of the data link layer, but for physical layer. What are improvements and evolution across different technologies? What is not available? What is now available more than was before? So there is not much happened except the improvement of symmetry parameters for getting the smooth sampling. According to the ISO, the bitrate has to be guaranteed to achieve actually the effectivity of symmetry parameters. Signal improvement is required, especially at very high bit rates. Anyways, there are new fast mode for high-speed transceiver, for XL transceiver, which is not available for other CAN technologies. Compatibility of those. Yeah, that is a little bit tricky. CAN-FT, CAN-XL is backwards compatible to CAN-FT. CAN-FT can easily tolerate CAN-XL, but classic CAN cannot tolerate any of them. So special circuitry, or rather, I'd say the solution from NXP, there is special transceiver having some capabilities of the controller should be used instead of just typical transceiver to prevent CAN CC node getting from the bus. Since it detects the wrong message, CAN-FT or XL, as an error and goes bus off until a bus off and will not be available. So a special measure should be used there. CAN-FT, in the contrary, doesn't need this. It tolerates CAN-XL message, and CAN-XL can, of course, tunnel any of those messages, any of those technologies inside. So, finally, when do the manufacturers come out, semiconductor manufacturers come out with their microcontrollers and so on? So I say they are soon be available. Currently is still as FPGA. Maybe in certain cases there are some boards available to check out. There are some tools available on the market. Since the both standards are already released, we would expect the semiconductors very soon. I cannot say where because I don't know myself, but I hope that will be available very soon. So now a couple more slides where we address the higher layer protocols in there. What is the impact and how does the features and bit fields already in a data frame, in a data link layer, helping out to do some recognition for the higher layer protocols. So this all stuff comes back to this zonal architecture. We need higher speed. We need to do some topology recognition. We do want to route the message much quickly and know exactly where. So there is some necessity for the things that were introduced since CiA. This is priority and addressing. So priority says how fast the message should be transmitted in there. And addressing field says where the message should go. In a routing table, in a gateway, this information will be provided, and the gateway will be routing this information, getting this information exactly from the frame itself. There are some add-ons, as we've spoken about, using several bit fields, such as this service data unit type, and so on. And there is also this bit extended content. So extended content means this is actually add-on function. And SDT, as we said, says about higher layer protocol, which is used in this one. SDT, various frames are available, can open FT coming also as well. There is no specific value, no specific type number for this, but we have certain reference in there where we can use this frame already then for CanOpen and CanOpenFT. Otherwise, for tunneling of Ethernet frames, it is easy done. J1939, ISO-TP transport protocol, and so on. They are also listed in this service data type, so I could recognize this by the type. Next thing is also interesting one. How do I transmit the large number of data? And I need to also coming from the zonal architecture, we saw the requirement in there. There was stated several various protocol types should be able to be transmitted up until this gateway and into the network. So the gateway should know about this. So that is why this multi-PDO unit is embedded in a message now, and having this special SDT number for that indicates exactly this, that I could hold couple of various protocols inside of the very same frame. Could be Ethernet, not the Ethernet frame, but it could be several CAN frames of different types, CanFT, several CanFT, or several J1939 things inside. And we have to distinguish them so we could route them into right place. That is why we've come up with special multi-PDU concept. It allows this compact, this contained PDU one by another. And this means also they can be the same protocols inside, can be different. For the moment, the different protocols are considered. Same could be used, but the optimized transmission with the same protocols, if there are several chunks of the same protocols, they are not yet designed. It will be in future implementation available. Finally, that is another property of this. The application decides how this contained PDU is ordered, how this part of this is ordered inside of this home message for multi-PDU frame. So that are briefly the concepts. Now where you can find standards and specifications, where do you see this, that you can see in the next slides. So I've separated between available and work in progress stuff. We have plenty of this. There are second slide to this one. So the first one is to say that a standard embedding 4 CAN technologies, or 3 technologies: classic CAN, classical CAN, CAN CC, CAN FT, CAN Excel, and CAN FT Lite for light application, which are also smaller, light weighted, and also for the blinking applications in a car is used. It is all standardized in ISO 11898-1. It's already available, could be used for the controller development, for the controller design. Also, transceiver can be designed, also standard is released. It contains all possible transceiver types, including transceiver combinations with signal improvement for FT and for Excel technology. We have the first version for this STU type, where you can find it. We are working on the next version. It will come very soon, hopefully. And then there are several things, they are still work in progress. And one thing I would like to mention, the part 2 was standardized for ISO 898-2, was released with some issues and with some not introduced comments. I'll put it that simple. We have already released also specification, which is available, you can see it on our website, for this improvement of what it was not done in the -2 standard. This is actually available, and all the technical improvements are already there. Just keep in mind if you develop in this. So the work in progress, there are plenty of specifications from data link layer, physical layer, guidelines, and so on. As I said it in the very beginning, we have standards for semiconductors and standards for their testing. So working also on the test plans, which will go into the standards, these so-called standards as well. We'll see this in the next few slides. And recently in some working group, we are working on these test plans in there. Higher layer protocols, additionally to the STU type, I've mentioned the multi-PDU, we also are close with release of this specification as well. So the main plan is this guideline how to design the system, meaning how to design controller and transceiver in tandem, how the network topology design should look like for CAN Excel networks, then also how do you implement PVM, in this case, decoding, encoding, how does it work? Then additional document, we will work on it or start work on it very soon. Finally, additional services for extended content is one I have not mentioned in there, this security and frame fragmentation. So security, we are working on. There is not very much to say about this. We're working hard on this. There is some progress, various possibility how to protect even data link layer from the intrusion, and there is frame fragmentation, fragmenting the message into very small fragments, chunk, allowing to interrupt the transfer of large message in there and continue on once the high prior message is already through the bus to continue from the next fragment. There is also necessity to simulate the topology, simulate the networks, which is why we had additional groups which are doing this, specification 910. Then standards I've already mentioned, released. And then for the people who would like to participate also in test plan development, we are still on the specification, this working group here, for both of them, and we plan standardization activities once we have a test plans designed that would start at least for the protocol controller in September of this year. Just good to know. Then I will summarize this. We're a little bit over time in this case, but we still have some minutes for the questions in there. Just so many things inside. CAN Excel is, CAN in general is robust technology. There is even a next third generation of CAN Excel capable of tunneling Ethernet frames, capable of higher speed, capable of used especially complying with requirements of zonal architecture for routing of the message and submitting, distributing various protocol messages inside of one frame, and so on. Higher layer functionality is supported, higher layer protection, also security is then will also be available, hopefully at a certain point. And then, as I said, it is possible to tunnel larger messages and other protocols such as Ethernet, and using scalable, for example, scalable service-oriented middleware over IP. In this case, that is what the today's requirement becomes satisfied. So if you want to have more information on CAN Excel, we have marketing activities going on CAN automation. So we have designed website, separate website. A side of ours you can access. The web address is listed in there. You will find some key features, possible application, physical layer options, meaning which kind of transceivers, which combination of hardware and software is available now for CAN Excel. Then few slides about CAN automation, what we also offer. You find us on social media. If you want to see us, one of the marketing activities of ours is we go to the exhibitions and show some products of our manufacturers, of our members in there. Next one will be InnoTrans in Berlin this year. Finally, you reach us on different topics. You reach us on different email addresses. Please keep this in mind. So you don't need to address the email into general email address, but there are some specific which are more suited for your needs.